Welcome to AZ-802, Practice Exam Hybrid Networking Deep Dive, Set 6. This focus session includes 36 original questions on Active Directory Integrated DNS, zones and records, forwarding, Azure DNS Private Resolver, DNS policies, DNSSEC, DHCP deployment, address troubleshooting, scopes, reservations, and DHCP failover. I will read each hybrid networking scenario and the answer choices. After the choices, you will hear "lock in your answer." Then the video pauses for a silent 3-second countdown. Pause the video if you need more time. After the countdown, I will reveal the correct answer, explain the deciding DNS or DHCP mechanism, and share one exam clue you can transfer to another scenario. Question 1 of 36. You create an AD-integrated contoso.com zone and select the replication scope to all DNS servers running on domain controllers in this domain. Where is the zone data stored? Option A, the configuration directory partition. Option B, the domain DNS zone's application directory partition. Option C, the schema directory partition. Option D, a local DNS zone file on every domain controller. Lock in your answer. The correct answer is B, the domain DNS zone's application directory partition. The selected domain-wide DNS server scope stores the zone in the domain DNS zone's application directory partition. ADDS then replicates that partition to DNS-enabled domain controllers in the domain. The phrase "all DNS servers on domain controllers in this domain" identifies the domain DNS zone's application partition, not generic domain or forest replication. Question 2 of 36. Domain-joined computers must register their own host records in contoso.com, but unauthenticated devices must not modify records. Which zone configuration meets the requirement? Option A, use an AD integrated zone and allow secure dynamic updates only. Option B, use a file-backed primary zone and allow non-secure and secure updates. Option C, use a secondary zone and enable zone transfers. Option D, disable dynamic updates and enable scavenging. Lock in your answer. The correct answer is A, use an AD integrated zone and allow secure dynamic updates only. Secure-only dynamic updates are available for AD integrated zones and use AD-DS authentication and ACLs to control record updates by domain principals. The paired constraints are self-registration by domain members and rejection of unauthenticated writers. That combination points to AD integration plus secure-only updates. Question 3 of 36. The parent zone corp.example is hosted by a separate enterprise DNS team. Your ADDS forest will use ad.corp.example, and its domain controllers must be authoritative for that child namespace. Which two actions establish the correct design? Option A, create an AD integrated primary zone named ad.corp.example on the domain DNS servers. Option B, create a conditional forwarder for ad.corp.example on the child domain controllers. Option C, create a secondary ad.corp.example zone on the parent DNS servers. Option D, ask the parent DNS team to delegate ad.corp.example to the child domain DNS servers, including required glue records. Lock in your answer. The correct answers are A and D. Option A, create an AD integrated primary zone named ad.corp.example on the domain DNS servers. Option D, ask the parent DNS team to delegate ad.corp.example to the child domain DNS servers, including required glue records. The child domain DNS servers need an authoritative AD integrated zone, while the parent namespace needs a delegation that directs resolvers to those authoritative servers. Glue records are required when the delegated name servers are inside the delegated namespace. Parent owned by another team plus child DCs must be authoritative requires both an authoritative child zone and a parent delegation. Question 4 of 36. Applications must connect to portal.contoso.com, while administrators need to change the underlying server name without reconfiguring clients. Which record should portal.contoso.com use? Option A, an MX record that identifies the destination server. Option B, a PTR record that maps the server address back to portal.contoso.com. Option C, a CNAME record that aliases portal.contoso.com to the current canonical hostname. Option D, an SRV record with port 443 and the destination server. Lock in your answer. The correct answer is C, a CNAME record that aliases portal.contoso.com to the current canonical hostname. A CNAME record provides a stable alias that can point to a different canonical hostname when the backend changes. The requirement is a stable, friendly name whose target hostname can change. That is, an alias to canonical name relationship. Question 5 of 36. A DHCP environment dynamically registers DNS records. Thousands of records remain long after clients leave, but manually created server records must never be removed automatically. What should you configure? Option A, shorten the zone TTL and enable round robin. Option B, convert the zone to a secondary zone. Option C, enable secure dynamic updates and configure a 7-day record TTL. Option D, configure zone aging and server scavenging with appropriate no refresh and refresh intervals. Lock in your answer. The correct answer is D, configure zone aging and server scavenging with appropriate no refresh and refresh intervals. DNS aging timestamps eligible dynamic records, and scavenging removes records that remain stale beyond the no refresh and refresh intervals. Static records are not scavenged unless explicitly timestamped. The decisive contrast is stale dynamic records versus preserved static records. Aging and scavenging are designed for exactly that life cycle. Question 6 of 36. A branch DNS server must host a read-only copy of contoso.com and refresh it only from 2 approved authoritative servers. Which configuration should you use? Option A, a stub zone listing the 2 authoritative servers. Option B, a secondary zone at the branch, with the primary zone allowing transfers only to the approved secondary. Option C, a conditional forwarder to the 2 authoritative servers. Option D, a forest-wide AD integrated replication scope. Lock in your answer. The correct answer is B, a secondary zone at the branch, with the primary zone allowing transfers only to the approved secondary. A secondary zone is a read-only transferred copy. The primary controls which servers may request transfers, and the secondary lists its master servers. Read-only copy and refresh from approved authoritative servers are zone transfer requirements between DNS servers, not forwarding or AD replication. Question 7 of 36. The research team will administer lab.contoso.com on its own authoritative DNS servers. Clients that query the contoso.com servers must be referred to the research servers. What should you create in contoso.com? Option A, a delegation for lab.contoso.com containing the research server's NS records and any required glue records. Option B, a CNAME record named lab that points to one research DNS server. Option C, a reverse lookup zone for the research subnet. Option D, a conditional forwarder stored only on one contoso.com server. Lock in your answer. The correct answer is A, a delegation for lab.contoso.com containing the research server's NS records and any required glue records. A delegation establishes a zone cut and refers queries for the child namespace to its authoritative name servers. Glue addresses are included when needed to locate in-bailiwick name servers. Independent administration of a child namespace plus authoritative referrals from the parent is a delegation scenario, not conditional forwarding. Question 8 of 36. Queries for partner.example must go only to the partner's DNS servers. All other recursive queries must continue using the existing server forwarders. What should you configure? Option A, a secondary zone for partner.example. Option B, a new root hints list containing the partner servers. Option C, a server-level forwarder that replaces the existing forwarders. Option D, a conditional forwarder for partner.example. Lock in your answer. The correct answer is D, a conditional forwarder for partner.example. A conditional forwarder applies only to the specified DNS suffix, preserving the existing recursive path for unrelated names. The word only, tied to one suffix while all other recursion remains unchanged, identifies a conditional forwarder on Windows DNS. Question 9 of 36. A DNS server has 3 forwarders. The first address is unreachable, and packet captures show each external query waits before trying the next address, creating predictable latency. Which change addresses the observed mechanism? Option A, enable scavenging on the DNS zone. Option B, change the zone replication scope to forest-wide. Option C, remove or reorder the unreachable forwarder and review forwarding timeout/fallback settings. Option D, create a PTR record for the first forwarder. Lock in your answer. The correct answer is C, remove or reorder the unreachable forwarder and review forwarding timeout/fallback settings. Windows DNS attempts configured forwarders according to its forwarding timeout behavior. An unreachable first target introduces delay before the next target or fallback path is tried, so the bad target and timeout sequence must be corrected. Packet captures showing a wait before the second forwarder isolate forwarder, ordering and timeout behavior rather than zone data. Question 10 of 36. Every DNS server running on a domain controller in contoso.com must receive the same conditional forwarder for partner.example without separate local configuration. What should you do? Option A, configure partner.example as a local server-level forwarder. Option B, store the conditional forwarder in ADDS and select the domain-wide replication scope. Option C, create a secondary zone on each DNS server. Option D, replace root hints on every DNS server. Lock in your answer. The correct answer is B. Store the conditional forwarder in ADDS and select the domain-wide replication scope. An AD-stored conditional forwarder can replicate to DNS servers in the selected domain or for scope, providing consistent suffix-specific routing without per-server objects. The requirements, same conditional forwarder, domain controllers, and no separate local configuration, point to an AD-stored forwarder with domain scope. Question 11 of 36. A server hosts an authoritative local zone named partner.example that contains an obsolete A record. You add a conditional forwarder for partner.example, but clients still receive the obsolete local answer. What should you change? Option A, correct or remove the authoritative local zone so queries can follow the intended forwarding path. Option B, disable root hints. Option C, add more target servers to the conditional forwarder. Option D, increase the forwarder timeout. Lock in your answer. The correct answer is A. Correct or remove the authoritative local zone so queries can follow the intended forwarding path. An authoritative zone is answered locally. The server does not use a conditional forwarder to bypass authoritative data for the same namespace. So the conflicting local zone must be corrected or removed. The server already holds authoritative data for the exact forwarded suffix. Authoritative local data wins before recursion or forwarding. Question 12 of 36. You deploy Azure DNS Private Resolver for bidirectional hybrid name resolution. On-premises clients must resolve records in Azure private DNS zones, and Azure workloads must resolve corp.contoso.com from on-premises DNS. Which two configurations are required? Option A. Configure Azure workload VNets to use the inbound endpoint IP as their custom DNS server. Option B. Configure the on-premises DNS servers with conditional forwarders for Azure private zone suffixes that target the resolver inbound endpoint IP. Option C. Link only the Azure private DNS zones to the hub VNet. No resolver rules are needed for Azure to on-premises queries. Option D. Create an outbound endpoint and rule set rule for corp.contoso.com that targets on-premises DNS, and link the rule set to the workload VNets. Lock in your answer. The correct answers are B and D. Option B. Configure the on-premises DNS servers with conditional forwarders for Azure private zone suffixes that target the resolver inbound endpoint IP. Option D. Create an outbound endpoint and rule set rule for corp.contoso.com that targets on-premises DNS, and link the rule set to the workload VNets. The inbound endpoint accepts forwarded queries from on-premises for Azure private namespaces. The outbound endpoint and linked forwarding rule set provide the Azure to on-premises path for selected on-premises suffixes. Bidirectional resolution has two different directions. On-premises enters through the inbound endpoint, while Azure exits through an outbound endpoint and linked rule set. Question 13 of 36. On-premises DNS servers must resolve records from an Azure private DNS zone linked to the VNet that contains Azure DNS Private Resolver. Which address should the on-premises conditional forwarder target? Option A. The IP address assigned to the private resolver inbound endpoint. Option B. The IP address assigned to the private resolver outbound endpoint. Option C. The Azure Platform DNS virtual IP 168.63.129.16. Option D. The resource ID of the DNS forwarding rule set. Lock in your answer. The correct answer is A. The IP address assigned to the private resolver inbound endpoint. The inbound endpoint exposes an IP address that receives DNS queries from on-premises networks over VPN or ExpressRoute. On-premises conditional forwarders use that IP for Azure private zone suffixes. The query direction is on-premises into Azure. Into Azure maps to the resolver inbound endpoint IP used by conditional forwarders. Question 14 of 36. Azure VMs use Azure-provided DNS and must resolve corp.contoso.com from on-premises DNS servers at 10.20.0.10 and 10.20.0.11. Which private resolver configuration supplies that path without assigning a custom DNS server to every VNet? Option A. An inbound endpoint and a private DNS zone named corp.contoso.com. Option B, an outbound endpoint, a forwarding rule set rule for corp.contoso.com targeting the on-premises DNS servers, and a rule set link to each workload VNet. Option C, a private DNS zone link with auto-registration enabled. Option D, a conditional forwarder on the on-premises DNS servers that targets 168.63.129.16. Lock in your answer. The correct answer is B, an outbound endpoint, a forwarding rule set rule for corp.contoso.com targeting the on-premises DNS servers, and a rule set link to each workload VNet. Azure-originated queries use the outbound endpoint when a linked forwarding rule set matches the suffix. The rule identifies the on-premises DNS targets, and VNet links make the rule set available to workload VNets while workloads continue using Azure-provided DNS. The direction is Azure to on-premises, while workloads retain Azure-provided DNS. That requires outbound endpoint plus suffix rule plus VNet rule set link. Question 15 of 36. A forwarding rule for corp.contoso.com works from two Azure spokes. A newly peered third spoke uses Azure-provided DNS but receives NXDomain for the same on-premises names. The resolver endpoints and rule targets are healthy. What should you change? Option A. Create a second inbound endpoint in the new spoke. Option B. Link the Azure Private DNS Zone for corp.contoso.com to the new spoke. Option C. Link the existing DNS forwarding rule set to the new spoke VNet. Option D. Configure the new spoke to use the outbound endpoint IP as a custom DNS server. Lock in your answer. The correct answer is C. Link the existing DNS forwarding rule set to the new spoke VNet. A forwarding rule set applies only to virtual networks linked to that rule set. Because identical queries work from linked spokes and the new spoke uses Azure-provided DNS, the missing VNet link is the isolated difference. The rule and endpoints work elsewhere. Only the new spoke differs, so the decisive boundary is the forwarding rule set VNet link. Question 16 of 36. Queries from 10.10.0.0/16 must receive records from the internal zone scope of contoso.com, while all other clients receive records from the default zone scope. What should you configure? Option A. A zone transfer policy that permits only 10.10.0.0/16. Option B. A recursion scope containing the internal records. Option C. A conditional forwarder for contoso.com. Option D. A zone-level query resolution policy with a client subnet criterion and an internal zone scope action. Lock in your answer. The correct answer is D. A zone-level query resolution policy with a client subnet criterion and an internal zone scope action. DNS query resolution policies can match a defined client subnet and select a named zone scope, enabling split-brain responses from one authoritative zone. The stem provides both the selection criterion, client subnet, and the response source, named zone scope, matching a zone-level query resolution policy. Question 17 of 36. A DNS server must deny any type queries for contoso.com only when they originate from a known scanner subnet. Normal A and AAA queries from that subnet must continue, and other clients must be unaffected. Which control is most precise? Option A. A response policy zone that replaces contoso.com with NX domains for every client. Option B. A DNS query resolution policy combining client subnet and query type criteria with a deny action. Option C. A zone transfer policy that excludes the scanner subnet. Option D. A recursion policy that disables recursion for all requests. Lock in your answer. The correct answer is B. A DNS query resolution policy combining client subnet and query type criteria with a deny action. A query resolution policy can combine multiple criteria, including client subnet and query type, and apply a deny action only when all required conditions match. Two simultaneous filters, source subnet and any query type, must match before denial. That is a multi-criterion query resolution policy. Question 18 of 36. A single authoritative contoso.com zone has east and west zone scopes. East client subnets must receive the east web addresses, while a migration subnet should receive 75% east and 25% west responses. Which design meets both requirements? Option A. Enable round robin on the default zone and create one server-level forwarder per region. Option B. Create one secondary zone per region and vary the SOA refresh interval. Option C. Create zone-level query resolution policies using client subnet criteria and weighted zone scope actions. Option D. Use recursion scopes with different route hints for east and west. Lock in your answer. The correct answer is C. Create zone-level query resolution policies using client subnet criteria and weighted zone scope actions. Zone-level policies can map client subnets to zone scopes and assign weights across scopes. Separate policies can give deterministic regional answers and a weighted migration response. The requirements combine client geography with weighted authoritative answers. Weighted zone scope actions are the mechanism that satisfies both. Question 19 of 36. A security requirement says resolvers must detect whether an authoritative DNS answer was altered in transit or forged. It does not require DNS query confidentiality. What does DNSSEC provide? Option A. Origin authentication and integrity validation for signed DNS data. Option B. Encryption of DNS queries and responses between client and resolver. Option C. Confidential storage of zone records on authoritative servers. Option D. Automatic blocking of every domain not signed with DNSSEC. Lock in your answer. The correct answer is A. Origin authentication and integrity validation for signed DNS data. DNSSEC uses digital signatures and a chain of trust to let validating resolvers verify the origin and integrity of DNS data. It does not encrypt DNS traffic. The STEM asks for tamper or forgery detection, but explicitly excludes confidentiality, isolating DNSSEC authentication and integrity rather than encryption. Question 20 of 36. You sign secure.contoso.com with DNSSEC. Validating resolvers outside your organization must build a trust chain from the signed parent, while an isolated Windows DNS resolver that cannot use that parent chain must still validate the zone. Which two actions address the two resolver populations? Option A. Enable scavenging on secure.contoso.com. Option B. Publish the child zone DS information in the signed parent delegation. Option C. Configure a conditional forwarder and disable validation on failure. Option D. Install the signed zone trust anchor on the isolated validating resolver. Lock in your answer. The correct answers are B and D. Option B. Publish the child zone DS information in the signed parent delegation. Option D. Install the signed zone trust anchor on the isolated validating resolver. A DS record in the signed parent links the child DNS key to the public delegation chain. A resolver without access to that chain needs an explicitly configured trust anchor for the signed zone. The STEM names two trust paths. Parent chain validation needs a DS delegation, while an isolated validator needs a local trust anchor. Question 21 of 36. A signed zone must rotate its DNSSEC keys without causing validating resolvers to reject answers during cache and delegation propagation. Which approach should you use? Option A. Delete the active keys first, then sign the zone with new keys. Option B. Convert the zone to unsigned during the rollover window. Option C. Keep only the old KSK and replace every ZSK immediately. Option D. Use the zone signing policy's staged key rollover so new keys and signatures propagate before old trust material is retired. Lock in your answer. The correct answer is D. Use the zone signing policy's staged key rollover so new keys and signatures propagate before old trust material is retired. A staged rollover overlaps old and new keys/signatures long enough for DNS caches and for KSK changes, parent trust information to converge before retirement. The operational constraint is uninterrupted validation during propagation. That requires overlap and staged retirement, not immediate key deletion. Question 22 of 36. You install the DHCP server role on a domain-joined server. The service logs that the server is not authorized and does not lease addresses to domain clients. What should you do? Option A. Create a reservation for the server's own network adapter. Option B. Configure option 006 with the domain DNS server addresses. Option C. Authorize the DHCP server in Active Directory domain services. Option D. Create a DHCP failover relationship. Lock in your answer. The correct answer is C. Authorize the DHCP server in Active Directory domain services. In an ADDS domain, an enterprise DHCP server must be authorized in ADDS before it services clients. Authorization prevents unauthorized DHCP servers from operating on the domain network. The event explicitly says "not authorized" on a domain-joined DHCP server. The corrective control is ADDS authorization. Question 23 of 36. Clients on the DHCP server's local subnet obtain leases. Clients on VLAN 30 do not, because routers do not forward their broadcast DHCP discover messages. You must keep one central DHCP server. What should you configure? Option A, a conditional DNS forwarder for the VLAN 30 namespace. Option B, a DHCP relay/IP helper on the VLAN 30 routed interface that targets a central server, plus an active scope for the VLAN 30 subnet. Option C, a superscope containing the local and VLAN 30 scopes without changing the router. Option D, a reservation for every VLAN 30 client. Lock in your answer. The correct answer is B, a DHCP relay/IP helper on the VLAN 30 routed interface that targets the central server, plus an active scope for the VLAN 30 subnet. A DHCP relay converts the client broadcast into a routed request and supplies subnet information, so the server selects the matching VLAN 30 scope. The failure exists only across a router, while the server must remain central. That is the classic relay plus matching scope requirement. Question 24 of 36. A multi-homed DHCP server leases successfully on NIC 1. Relayed DHCP discover packets arrive on NIC 2 and are visible in a packet capture, but the DHCP audit log shows no request on that interface. DNS and scope configuration are correct. DHCP server bindings show NIC 2 is unchecked. What should you change? Option A. Change scope option 006 to NIC 2's address. Option B. Authorize the relay agent in ADDS. Option C. Reduce the scope lease duration. Option D. Enable the DHCP server binding on NIC 2 and confirm the DHCP firewall rules permit the interface. Lock in your answer. The correct answer is D. Enable the DHCP server binding on NIC 2 and confirm the DHCP firewall rules permit the interface. The service listens only on enabled DHCP bindings. Enabling NIC 2 lets the DHCP service receive packets arriving there. The DHCP firewall rules must also allow the server traffic on that interface. Packets reach NIC 2 but never enter the DHCP audit path, and NIC 2 is explicitly unbound. The listener binding is the decisive evidence. Question 25 of 36. A relay forwards DHCP discover packets from 10.40.8.0/24 to a central DHCP server. Captures on the server show GIA DDR equals 10.40.8.1, but the server sends no DHCP offer. The service is authorized and other subnets receive leases. What is the most likely cause? Option A. Option 006 is missing from the server-level options option B. No active DHCP scope has a network ID matching the GIADR subnet. Option C. The client has no DNS suffix. Option D. The server lacks a conditional DNS forwarder for 10.40.8.0/24. Lock in your answer. The correct answer is B. No active DHCP scope has a network ID matching the GIA DDR subnet. For relayed requests, the server uses GIA DDR to identify the client subnet and select a scope. Without an active scope matching 10.40.8.0/24, it has no eligible pool from which to offer an address. The request reaches an authorized server, and the trace exposes GADDR. The missing matching scope is the remaining scope selection failure. Question 26 of 36. A Windows client shows 169.254.37.12/16 after startup and has no DHCP lease information. What should you investigate first? Option A, the DHCP discovery/offer path between the client and an available scope. Option B, the DNSSEC trust anchor on the client's resolver. Option C, the DNS suffix search list. Option D, the conditional forwarder used for the client's application domain. Lock in your answer. The correct answer is A, the DHCP discovery/offer path between the client and an available scope. An address in 169.254.0.0/16 indicates automatic private IP addressing after the client failed to obtain a DHCP lease. The first investigation is the DHCP path, link/VLAN, relay, server availability, and scope capacity. A PIPA plus no lease data at startup is direct evidence of failed DHCP address acquisition, not a DNS or DNSSEC problem. Question 27 of 36. A laptop moves from subnet 10.20.1.0/24 to 10.20.2.0/24 and sends DHCP request for its previous 10.20.1.55 lease. The DHCP server returns DHCP NACQ. What should the client do next? Option A, continue using 10.20.1.55 until the original lease expires. Option B, register a new DNS-A record for 10.20.1.55. Option C, restart DHCP discovery to obtain an address from the 10.20.2.0/24 scope. Option D, request a longer lease for 10.20.1.55. Lock in your answer. The correct answer is C, restart DHCP discovery to obtain an address from the 10.20.2.0/24 scope. A DHCP NAK tells the client that the requested address is not valid on the current network. The client must abandon it and restart discovery so the server can offer an address from the new subnet scope. The decisive evidence is DHCP NAK after a subnet move. The client must discard the old address and return to discovery. Question 28 of 36. After a VPN ACL change, remote clients receive a PIPA addresses. The relay captures their DHCP discover broadcasts, but the central DHCP server captures no corresponding relayed packets. Local clients still lease successfully, and the remote scope is active. What should you correct? Option A, create exclusions for the remote scope. Option B, reauthorize the DHCP server in ADDS. Option C, change option 015 on the remote scope. Option D, restore the relay to server UDP DHCP path and verify the helper target address. Lock in your answer. The correct answer is D, restore the relay to server UDP DHCP path and verify the helper target address. The failure occurs between relay and server. Broadcasts reach the relay, but relayed requests never reach the central server. The VPN/ACL path and configured helper target must allow the DHCP server traffic. The packet boundary is explicit, visible at relay, absent at server immediately after an ACL change. That isolates the routed relay to server path. Question 29 of 36. Addresses 10.50.4.20 through 10.50.4.39 are statically assigned to network appliances. They fall inside an active DHCP scope and must never be offered dynamically. What should you configure? Option A, an exclusion range for 10.50.4.20-10.50.4.39. Option B, a shorter lease duration. Option C, a superscope containing the appliance range. Option D, a DHCP policy based on DNS suffix. Lock in your answer. The correct answer is A, an exclusion range for 10.50.4.20 from 10.50.4.39. An exclusion range removes the static block from the scope's dynamic allocation pool, while leaving the rest of the scope available. A contiguous static block inside a DHCP scope that must never be leased is specifically an exclusion range requirement. Question 30 of 36. All scopes should provide the same DNS servers, but only the 10.60.7.0/24 scope must provide 10.60.7.1 as its default gateway. Where should you configure option 003? Option A, at the server level, replacing the shared server options. Option B, at the 10.60.7.0/24 scope level. Option C, as a reservation option for every client. Option D, in a superscope that contains every scope. Lock in your answer. The correct answer is B, at the 10.60.7.0/24 scope level. Scope level option 003 applies the subnet-specific router value only to clients in 10.60.7.0/24, while shared DNS options can remain at server level. The gateway varies by subnet, while DNS remains global. Place the differing router option at the scope level. Question 31 of 36. One physical broadcast segment contains two routed IPv4 networks, 10.70.1.0/24 and 10.70.2.0/24. The Windows DHCP server must lease addresses from both logical networks on that multinet. Which two configurations are required? Option A, create a separate DHCP scope for each logical subnet. Option B, create 1/23 scope even though the routers advertise 2/24 networks. Option C, use one scope and place the second range only in an exclusion. Option D, group the two scopes in a superscope. Lock in your answer. The correct answers are A and D. Option A, create a separate DHCP scope for each logical subnet. Option D, group the two scopes in a superscope. Each logical subnet needs its own scope because a scope represents one subnet. A superscope groups those scopes so the DHCP server can service a multinet on one physical segment. The stem says two logical networks share one physical segment. Separate scopes model the subnets, and a superscope models the multinet. Question 32 of 36. A scope distributes 192.168.40.50 to 192.168.40.200. You try to reserve 192.168.40.20 for a printer, but the DHCP console rejects the reservation. What should you do? Option A, create a DNSA record for 192.168.40.20 first. Option B, add 192.168.40.20 only as an exclusion. Option C, choose a reservation address inside the scope distribution range and bind it to the printer's client identifier. Option D, shorten the scope lease duration. Lock in your answer. The correct answer is C. Choose a reservation address inside the scope distribution range and bind it to the printer's client identifier. Windows DHCP reservations must use an address within the scope's distribution range. Select an in-range address and associate it with the printer's MAC client identifier. The rejected address is in the subnet but outside the configured distribution range. Reservation eligibility follows the scope range. Question 33 of 36. A printer must remain DHCP managed, but always receive 10.80.5.25 when it requests a lease with its known MAC address. What should you configure? Option A, an exclusion for 1080.5.25 with no other DHCP object. Option B, a static DNS A record only. Option C, a shorter lease duration for the printer user class. Option D, a DHCP reservation that maps the printer's client identifier to 10.80.5.25. Lock in your answer. The correct answer is D, a DHCP reservation that maps the printer's client identifier to 10.80.5.25. A reservation binds a known client identifier /MAC address to a preset address while the device continues using DHCP. The device must use DHCP yet receive one stable address based on MAC. That is precisely a reservation. Question 34 of 36. A branch DHCP server should service all clients normally. A data center partner should remain passive and use a small reserved percentage only if the branch server becomes unavailable. Which failover mode fits? Option A, hot standby mode. Option B, load balance mode with a 50-50 ratio. Option C, a super scope. Option D, two unrelated active scopes with overlapping ranges. Lock in your answer. The correct answer is A, hot standby mode. Hot standby designates an active server and a standby partner. The standby has a reserve percentage for new leases during an interruption and is intended for temporary takeover. One active branch server plus one passive data center backup with a reserve percentage describes hot standby rather than load balancing. Question 35 of 36. A hot standby partner has lost contact with the active server. The active server is confirmed offline, and the standby must safely use addresses beyond its reserve for new clients without risking duplicate leases. Which two actions/conditions are required? Option A, leave the relationship indefinitely in communications interrupted state. Option B, place the relationship in partner down state after confirming the partner is unavailable. Option C, allow the maximum client lead time, MCLT, safety interval to elapse before full pool use. Option D, delete and recreate the failover relationship. Lock in your answer. The correct answers are B and C. Option B, place the relationship in partner down state after confirming the partner is unavailable. Option C, allow the maximum client lead time, MCLT, safety interval to elapse before full pool use. Partner down state tells a survivor that the partner is unavailable, rather than merely unreachable. The MCLT safety interval protects leases that might have been issued by the missing partner before the survivor uses the entire free pool. Confirmed partner failure requires both an explicit partner down transition and the MCLT safety boundary before unrestricted takeover of the address pool. Question 36 of 36. You change option 006 on a failover-enabled scope on DHCP1. DHCP2 still gives clients the previous DNS server list, while lease synchronization is healthy. What should you do? Option A, recreate the failover relationship. Option B, wait for lease replication to copy the option automatically. Option C, change both servers to load balance mode. Option D, initiate replication of the updated failover scope from DHCP1 to DHCP2. Lock in your answer. The correct answer is D. Initiate replication of the updated failover scope from DHCP1 to DHCP2. Changes to failover-enabled scope settings are not automatically synchronized merely because leases replicate. Initiating scope replication copies the desired scope settings from DHCP1 to its partner. Healthy lease sync plus one stale scope option identifies the documented need to manually replicate changed scope settings from the authoritative partner. You finished the hybrid networking deep dive. Sort any misses into 5 boundaries: authoritative DNS data, recursive query routing, Azure hybrid resolver direction, DHCP scope selection, or DHCP high availability state. Replay only the patterns you missed to build a precise remediation plan. Thanks for practicing with WebLizard CertLab. Keep authority, query direction, subnet evidence, and failover state in view, then continue with the next AZ-802 deep dive when you are ready.